Black powder is a mixture of saltpeter, charcoal, and sulfur. The typical composition is 75% saltpeter, 15% charcoal, and 10% sulfur by weight, but there can be some variation in the percentages. If you see potassium nitrate or sodium nitrate mentioned instead, those are simply specific types of saltpeter from what I understand. But I'm not a chemist, so take this with a grain of sodium chloride. Modern smokeless powder, despite its term, still generates some smoke during combustion, just nowhere near as much as black powder. There is much more variation in smokeless powders. They can be made of quite different ingredients and have different purposes. They burn very efficiently and turn most of their mass into gas, so they don't foul up the firearm much at all compared to black powder. Let's have a little visual demonstration of the difference between smokeless and black powder. First, the smokeless powder. As you can see, it just burns slowly. It only generates pressure when combusting in a closed space inside of a cartridge. And now the black powder. Despite a smaller amount, it looks much more volatile, doesn't it? When burning in open air like that, the black powder looks more powerful, but it really isn't. Smokeless powder burns progressively, which means that the burn rate increases as the pressure inside the chamber of the firearm increases. So as it burns, the pressure rises, and in turn the elevated pressure makes the powder burn even more quickly, which again elevates the pressure. You get the idea. That's why smokeless powder is much more potent and can easily damage a firearm if you accidentally load even just a little too much powder. Black powder burns degressively, which means that the rate of energy release is decreased as it continues burning. So the pressure increases quickly at first and then drops off again. Black powder guns are loaded by volume, whereas smokeless powder is measured by weight in grains. 1 grain is about 65 milligrams. Precise measurement is not as important with black powder as it is with smokeless. Whether you load 70 or 75 volumetric grains has very little effect on bullet velocity. If, on the other hand, you measure smokeless powder by weight, you better be precise. For example, if I load 9 grains of Hodgdon HS6 in a 45 Colt cartridge with a 250 grain lead bullet, that's a very light load with low recoil. If I load 10 grains, it's a fairly stout load that will kick noticeably, and if I load 10.5 grains, it's getting close to the maximum recommended charge. I usually load 9.5 for target practice, and here you can see just how little powder that is inside the case. I need to be very careful to avoid accidentally loading it twice, because 19 grains would be potentially catastrophic. On the other hand, I can also load the 45 Colt with black powder, and that's what they used in their single-action revolvers back in the day. Now I can actually fill the entire case with powder, and in fact I should fill it all up, or otherwise use some kind of filler material if I want a reduced load, because there should never be a gap when loading black powder. If you have air between the powder and the bullet, you basically have a pipe bomb. Smokeless powder does not cause the cartridge to explode despite a lot of air inside. I've been unable to find a straightforward explanation for why that is, and I've always been terrible at physics and chemistry. I can only imagine that the way black powder combusts, the compression of the air makes the pressure push outwards rather than just against the ball or bullet. If somebody has a simple explanation for that, let us know in the comments. Here's a very important thing to note. Never ever use smokeless powder in firearms that were designed for black powder. Even if it's modern reproductions, that would be extremely dangerous. Basically, if you only destroy your gun doing that and still have all your fingers afterwards, you can count yourself lucky. By the way, black powder is not technically shock sensitive, but manufacturers usually advise to avoid impact and friction. I'm assuming that's because impact could theoretically cause a spark, even if it's very unlikely, and that could of course ignite the powder. Friction, yeah, that's pretty self-explanatory. Heat can set it off. Compared to modern smokeless powder, black powder burns a lot less efficiently. When burning 1 gram of black powder, it leaves about half a gram of solid residue behind. A lot of that will accumulate in the barrel of the firearm and also the chambers in case of a revolver. That's why it's important to use grease when loading a black powder gun, which prevents the residue from forming hard crud, which gives the bore, which is the inside of the barrel, an uneven surface and fills the rifling if there is any. There are different grades of black powder based on the granulation. FG powder is very coarse and used for cannon. 2FG powder has smaller kernels and is used in large caliber rifles and pistols. 3FG is the finest granulation used as the main charge. It's for 50 caliber and smaller, although sometimes the recommendation is 45 caliber and smaller. In historical times they apparently mixed up different granulations, but nowadays we just use one at a time. The finest powder, 4FG, is only used as priming powder to put in the pan of a flintlock. The finer granulations generate higher pressure, so loading a full charge of 4FG powder in a 62 caliber musket would be disastrous. Bursting the barrel, shooting shrapnel and hot gases in your face, that kind of disastrous. The general rule of thumb is that you can safely load the caliber in grains. So in a 54 caliber barrel you can load 50 or 55 grains of powder. In percussion revolvers, this rule doesn't quite apply. For example, the recommended charge in a 31 caliber pocket revolver is 15 grains. However, revolvers make it easy anyway because the chambers in the cylinder have a limited capacity. So cramming as much powder into them as you can will not generate excess pressure. It's always best to look up the maximum recommended charge, which can be over 100 grains in a musket. Of course, there is a lot more you can say about Blackpowder, but I think this should suffice for an introduction. Finally, I'll show you the dramatic visual difference between firing the same cartridge in the same revolver with Smokeless compared to Blackpowder. Thanks for watching. Compared to Smokeless, manufacturers usually can't speak, but manufacturers, why is that so difficult to pronounce? That's why it's important to use grease when looting? The general rule of thumb is that you can this is more difficult than you might think, because the chambers in the cylinder dramatic visual differences dramatic visual difference between firing the same cartridge in your revolver